Alright students, today we're on lesson 5-7, solving unit rate problems. You need pages 305 to 309 tore out of your book. And while you're getting that done, remember that yesterday in 5-6 we talked about finding the unit rate and then comparing unit rates. So when we get the denominator to be a 1, then we can compare the numerators to see which is larger or greater than the other one. Alright, in this solve and discuss it says, suppose you're traveling by train to visit a friend who lives 275 miles away. That's a distance. That's a D in our little formula that we used yesterday. How long will the trip take? So we're trying to find T, time. And remember that distance equals rate times time. Alright? There's one question. Then it says moving at a constant rate. How long? Again, they want to know a time. Would it take the train to travel 385 miles? Okay, so we're going to come down here and we're going to work on this. You'll have to be looking back at this information. Alright, so we know this. Distance equals rate times time. And I showed you a little way to help remember what to do. If you know a rate and a time, you multiply those to get distance. If you know a rate and a distance, you're going to divide distance by rate to get a time. If you know a distance and a time, you're going to divide those to get a rate. Okay, so let's see what we've got. In the first case, we have a distance of 275 miles. And we know that the rate is 55 miles per hour. It said so right here in this little blurb. When it's somebody's talking, that's called a blurb. So in this little, here's our rate right here. Our R is 55 miles per hour. Okay, so we have an R that's 55 miles per hour, and we want to go find T. That's what's missing. In the other case, we have a D that is 385 miles, and we have an R that's 55 miles per hour. Miles per hour. And again, we want to find T. So we have two cases. Now, if you look at our little model here, we have a D and an R. And this means divide. So we need to take the distance, divide it by the rate to get the time. So we're going to take distance, which is 275 miles, divide it by 55 miles per hour. And that's going to give us, miles are going to cancel, it's going to give us our answer. It's going to give us T. It's going to give us T in hours. Over here we're going to do the same thing with 385. We're going to set both of these up, and then we're going to use our calculator to punch them in. And this is 55 miles per hour. Miles cancel, and it's going to give us our time in hours. Okay? So, get your calculator out, take a moment, and let's punch this one in. 275 divided by 55 gives us 5 hours is what T is equal to. This one over here, 385 divided by 55 gives us 7. 7 hours is what T is equal to here. It asked how long it would take this train, how long it would take this train. So there's our two answers that it asked us up there. Look down here at the focus on math. Suppose the train was traveling at a constant speed that is twice as fast as 55 miles per hour. Twice as fast. How long would it take the train to go 275 miles? Okay, so if we look right here, if we were going 275 miles and we divided it by a number that was twice that big, it should cut that number in half. But what is twice 2 times 55? 55 times 2 is 110. So we want 275 divided by 110, and that's going to give us T, which is 2.5. Now, didn't we say our reasoning was 2.5 hours? If we double this, then we're going to be dividing this numerator by twice as big a number, which should cut that number in half. So when we did it, is 2.5 half of 5? Is 2.5 half of 5? And yes, it is. Okay? When you double the rate, it should cut the time in half because the rate is in the denominator. Okay? Let's turn the page and go look at example 1. The jet flies at a constant speed. Constant speed means the speed stays the same over time. If the jet continues to fly at the same rate, rate is the same thing as speed, how far, when it says how far, it's looking for a distance, a d. Could it fly in 85 minutes? Okay, so let's see what they said right here. The jet flies 175 miles in 7 minutes. So we're going to get our rate from here. We have a time, right here's a t. We're looking for a d, how far is the distance, and right here, here's our rate. The rate is 175 over 7. We need to turn that into a unit rate, so 175 divided by 7 is 25. So that's 25 miles per hour. Okay, so now we have an R. We have a T that is 85 minutes. We have an R that's 25 miles per hour, and we're looking for a D. Now remember our little model? Distance is equal to rate times time. So if I have a rate and a time, I'm supposed to multiply to get a distance. So my D is going to be 85 times 25, and it's going to come out in miles. 85 times 25, and that's 2125. So the distance is 2125 miles. Now we're going to look at what they did down here. They said, here's my 175 in 7 minutes. So they went backwards to get their unit rate. Here, one way to do it. Then they could build their table. What do I have to multiply this by? If I multiply 1 times 85, I get 85. So if I multiply 25 times 85, I get this. Here's your answer right here. So they just built the table and then looked for the answer. Another way, see there's more than one way here, use the unit rate to find how far the jet could fly in 85 minutes. So here they got their unit rate. Here's their unit rate. And then they multiplied it by 85 like we did yesterday on yesterday's homework. And then they got 2125 in 85 minutes. They found this equivalent ratio, and that gave them their answer. So really on this piece of paper there are 3 ways. The 2 ways they showed you and the way I showed you. All right, let's go to the try it. And we got to look at this because we have to fill in their blanks. At the same rate, how far would the jet fly in 75 minutes? How far would the jet fly in 75 minutes? Okay, up here we found out that the rate the jet flies is 25 miles per hour. Okay, how far would it fly in 75 minutes? So we want We want the rate, which is 25 miles every 1 minute. And then we want to multiply that by, that's the rate, times the time, which is 75 minutes. And we have to multiply that by 75 also. 1 times 75 is 75, and 25 times 75, use your calculator and see what that is. 25 times 75 is 1875. Sometimes it's harder to fill in their chart than it is to do it on your own. Okay, let's look at example 2. Solving unit price problems. This looks like we're at the grocery store buying Swiss cheese. Grocery Giant is having a sale on Swiss cheese. How can you use the unit price to solve the problem? Let's see, 24 slices for $7.20. So we put this in our chart, and 24 divided by 24 is 1. And I need to know what $7.20 divided by 24 is. And it's 30 cents, and that's how they got that right there. Okay? Now, we want to buy 5 slices of cheese. So we want to know this right here. So we just take that amount right there and multiply it by 5 to get this and this. 5 slices and 5 slices. That's one way. What's another way? Use the unit price to solve the problem. So, we use the unit price. Here's my unit price, 30 cents per slice, and multiply top and bottom by 5. 5 slices, 5 slices. And you get the same answer right here as we got right there in that row. Okay, 2 different ways to do the same problem. All right, let's look at the try it. Jared paid $13.80 for 5 tickets. So we're going to take that $13.80, we're going to divide it by 5. Divide by 5, divide by 5. We want to get the unit rate. What is $13.80 divided by 5? $2.76. Okay, so it's $2.76 for 1 slice, and we want to know 5 slices. So we multiply by 5 and multiply by 5. $2.76 times 5 is $13.80. Oh, 3. I'm sorry, 3. Make that be a 3 right there. 3. I started to say we went right back to what we started with. We want $2.76 times 3. Which is $8.28 for 3 slices. Okay, you have to find out what 1 is, and then you can multiply it by however many slices they ask for after that. All right, let's look at example 3. Use an equation to represent unit rate problems. A ferry boat travels at a constant speed of 57.5 miles in 2.5 hours. How long would it take the ferry boat to travel 92 miles at that rate? Okay, here's their chart with time and distance. They're going to go this many miles in this much time. So let's see if they take 57.5 and divide it by 2.5, then you get the 23 miles per hour. So there's their rate right there. Okay? Now then, we're going to find the time. Now look at what they've got right here. Distance equals rate times time. I've been showing you this for 2 days. Rate times time. I use a dot instead of an X. The equation shows that distance is the product of rate and time. So we're going to substitute 92 for the distance and 23 for the rate. And then we're going to divide both sides of the equation by 23. And this is what I showed you the other day. Distance equals rate times time. In this one, you have a distance and you have a rate. That's why you're dividing. See, you're dividing right here. Okay, so it would take 4 hours for the ferry boat to travel 92 miles. All right, let's look at the try it. Be reading it. All right. Make sure when you're reading it you pay attention to what is distance, what is rate, and what is time. A submarine travels 19 miles. That's a D. In half an hour. That's a T. Write an equation to find out how long it would take the submarine to travel 57 miles at the same rate. Okay? So we have distance equals rate times time. We have a distance of 19. We have a rate that we don't know times a time of 1/2. And I'm going to use parentheses here. Okay, so how do we get this r by itself? Well, we divide both sides by 1/2, or we multiply by the reciprocal. Remember that terminology? So 2 over 1 times 19 is 38 is equal to, and this all cancels, is equal to r. So it's 38 miles per hour. 38 miles for 1 hour. That's the rate. And all I did was follow that little equation right there. And I did my one-step equation. Okay? All right, let's go to our key concept. You can use ratio tables or unit rates. Ratio tables or unit rates to solve rate problems, including constant speed problems. The ant travels 6 centimeters in 1.5 seconds. That's a rate. Okay? 6 centimeters in 1.5 seconds. So we want to find this unit rate right here. Okay, so they double that, got 3, they double that, got 12. They kept going with a number and going up each time. Every time this grew 1.5, this one grew by 6. By 4. No, by 6. 6 and 6 and 6, yes. Okay, then what if we want to go backwards? Okay, well, let's see. 6 centimeters to 1.5 seconds. So we need to divide by 1.5 and divide the 6 by 1.5. So 6 divided by 1.5 is 4. So it's going to go 4 centimeters in 1 whole second. And that's where they got their unit rate right there. Just like we've been doing all through the last few lessons. All right. Let's go to number 1. Do you understand? How do we use unit rates to solve problems? You can make a table. Or find and use the unit rate. Find and use the unit rate. Just like we did on the other side of this paper. You can make a table, or you can find and use the unit rate. Number 2. Oh good, we get a problem with an animal, and I like animal problems. An ostrich runs 6 miles in 12 minutes. at a constant speed. Explain how you can use a unit rate to find how far the ostrich would run in 40 minutes. So we're going to explain it by working it. Okay? So we're in, let's see, 6 miles in 12 minutes. You understand to put the distance on the top? Because it's going to be, it makes sense to say miles per minute. It doesn't make any sense to say minutes per mile. Do you hear that? It sounds goofy. We're going to go miles per minute, not minutes per mile. Okay, now we want this 12 to be a 1. So we're going to divide by 12, divide by 12. So now we have 1 minute down there. And what is 6 divided by 12? Well, that's a half. I'm going to put 0.5 there, miles. Half a mile. We're going to go half a mile in a minute. Now I'm going to use this unit rate and I'm going to multiply by 40. So times 40 times 40, half of 40 is 20. 20 miles in 40 minutes. Just like we've been doing. Find your unit rate. Unit means the bottom number is a 1. And then multiply it by whatever you want to turn it into. In this case, it was 40 minutes. Okay, number 3. Bananas sell for 58 cents per pound. That would be like a rate. Dollars per pound. How could you write an equation to show the relationship between the total cost and the number of pounds? Well, just like we have distance equals rate times time, your cost is going to equal the rate, the amount it is per pound, times the number of pounds that you buy. The cost, C, is going to be equal to the price per pound times the number of pounds that you buy. All right, number 4. Do you know how? Football player runs 80 yards in 25 seconds. See, we don't say he runs 25 seconds for 80 yards. We say we run 80 yards a distance and a time. So he does 80 yards in 25 seconds. If he maintains the same rate of speed. So we want to turn that into 1 second. So divide by 25, divide by 25. It's your denominator that tells you what to divide by. So this is a 1 second now. How far can he go in 1 second? What's 80 divided by 25? 3.2. So 3.2 yards, a little over 3 yards in 1 second. Now how far could he run in 60 seconds? So now we're going to take that and multiply by 60 by 60. So times 60 is 192 yards that he's going to go in 60 seconds. See, we had to take this and find out what it was for 1 second, and then we can multiply that times any number we want to. In this case, they asked for 60 seconds. Okay, number 5. On a family vacation, Amy's dad drove the car at a constant speed and traveled 585 miles. Okay, that right there is a D, distance. In 13 hours, that's a T. At this rate, how long would it have taken the family to travel 810 miles? So let's go find the unit rate. We're going to go 585 miles in 13 hours. Let's turn that into 1 hour. So we're going to divide by 13, divide by 13. What's 585 divided by 13? 45. So he's going 45 miles every hour. Okay? Now then, At this rate, how long would it have taken the family to go 810 miles? So now this is an R, and we have a D of 810. So distance equals rate times time. We have a D and we have an R. Or think about my model. We have a D and we have an R. So we need to take D and divide it by R. Let me show you with this equation right here first. We're going to put 810 miles in place of D. We have a rate, which is 45, and we're going to multiply that times T. Now, in order to solve that, we have to divide by 45. Well, aren't we dividing by the rate? So aren't we taking the distance and dividing by the rate? See that? So what is 810 divided by 45? I get 18. So it's going to take 18 hours to go 810 miles. Okay, now I'm going to leave number 5 up there. Look at exercise 5 and write an equation to find the total distance D that Amy's family, traveling 45 miles per hour, times after T times. So it's D equals the rate we know times time. You give me time, I can multiply that and give you D. You give me D, I can divide and give you T. Okay, this video again is about 27 minutes long, and you have some work to do in class with your teacher. You have a practice and problem solving page to do that looks like this. Sorry I don't get to do the horse problem with you. And then you have a reteach and a vocabulary to do. I suggest you do the reteach first, reteach side, and then the vocabulary or whatever you have time to do. If you have to look some of these things up by looking back in your book, please do that. There's a quiz provided if you have time, teachers, or if you want to make time to do that. And that is all for 5-7. And I hope you're all getting this really good understanding, and I'll see you next time. Get your work done.